Hello and welcome to another SimHERA tutorial in the SimHERA Academy lessons. In this tutorial we will walk through lab number 5, which demonstrates how to use SimHERA to conduct evoked response audiometry on an infant referred from newborn hearing screening. If you'd like to follow along, you will find the links to the lab handout and case file in the description below. Let's get started. Okay, first thing we need to do is load that case that you received from your instructor or you downloaded from the links below. Lab number 5. We're going to use new assignment. This is a new assignment. All right, so the next thing we need to do is review the case. Infant was referred from newborn hearing screening, complicated birth, child born full term, was in neonatal intensive care for 1 week, and no family history of elevated hearing thresholds. Okay, so we have an idea that this is a possible sensorineural hearing loss, but we can't assume everything. So we're going to go through and do our testing. And the first thing to do would be to set up the baby. I'm going to do the cheat and do this a quick way for sake of the video timing here. We've got the infant set up and we're going to go to the evoked responses and see the EEG is updating, and we'll change the artifact rejection limits there. Now, unless the infant was awake and wasn't able getting to sleep, we would typically do OAEs and tympanometry, but this baby is asleep, so we wouldn't waste sleep time by doing those, and we're going to continue right on to do our evoked response audiometry testing. And because it's an infant, the best tests for that for threshold are ABR. So make sure you're in the ABR module there, and we go ahead and start session. And we're going to start off with our 5-cycle tone, 2000 Hertz. And I like starting in the left ear. That's how SimHERA is actually programmed up. Start in the left unless otherwise noted, because we have some information, but we didn't have any other previous information about what ear to start on. And we're going to make sure that we've got our masking off and everything looks great. Now, just to note, I'm going to have the recordings being sped up here, so it's going to not be in real time for this video. It's actually 8 times speed for when we do the recordings, and this is just to help shorten the video time. But when you're performing this yourself, you'll note that the time for these updating of the waveforms to be collected is about 8 times slower. Okay, so our first condition is 30 dB, 2000 Hertz left ear AC IPSI channel. Go ahead and click acquire. And again, this is a lot faster in updating for the number of sweeps being collected. It wouldn't be that fast. And we'll do another replication here. And it looks like there is a wave 5 there. So I'm going to go ahead and do the averaging and label that with a wave 5 so I know that we have a response being present. So we've tested the left ear at 2000 Hertz. We have a response present. The next condition is to switch ears because we're going through that ear-specific hearing elevations. Then the next one is the type of hearing loss, and then the next priority is the actual threshold. So right ear, we're going to hit acquire. Looking reasonably flat, but we need another replication here. And I'm seeing that that's quite flat, and it is meeting our noise criteria of less than 0.04. So I'm going to classify that as a no response. So we have an elevation in the right ear. The next thing to do is to determine the type of hearing loss. That could be in the right ear. So whether it is conductive or sensorineural. And the best way to do that is using bone conduction. So we got bone conduction, both channels being on, and 2000 Hertz. Go ahead and click acquire. And another replication. And so that is looking relatively flat for me in the IPSI channel, and yes, we're meeting our noise criterion. So I'm going to classify that as a no response there. And the contralateral channel, there might be a tiny response, but I'm not sure. But we definitely have a no response in the That's such a tiny response. I'm going to classify that as a no response for now. And we are going to clear these because the next condition is to go up to 60 dB. And I need a little bit of space there. So we're going to go 60 dB and see what we get. That's looking like a nice response, and it actually looks like it's coming more so from the contralateral, in the contralateral channel, so that we could be having some crossover going on here. And that would make sense, because if I plot back up the left channel, we did, our left ear response, we did have a response at 30 dB. So this could be crossover hearing activation of the right cochlea, and that's what that is looking like. But we can't be sure whether or not there is an ipsilateral response underlying this. So how we reconcile that, or try to, is to put in contralateral masking to reduce this contralateral response here. And for 60 dB, our upper limits is 85 dB. An easier way to do sometimes that is just to clear it and replot it, and it automatically replots. So this is definitely looking like a wave 5 here. And you can right click and go peak info, and that will give you the information for the latency and amplitudes. Just to be clear, it's pretty obvious to me just by looking at the waveforms that yes, it's peaking earlier and the amplitude's a little bit larger in the contralateral channel. So this gets an inconclusive result of judging whether or not the ipsilateral cochlea is responding, because we are unsure if there is an ipsilateral response underlying this, what looks like contralateral activation from the contralateral cochlea. So that masking is going to hopefully help reduce that. But this is how we make our judgment. Okay, so let me just label these. Okay, so we're going to go ahead and collect same condition, except for we have the contralateral masking going on. And we'll do another replication here. And look at that, the ipsilateral channel now has a response. That's a nice clear wave 5 there. And just to show the average. And the contralateral channel doesn't quite meet noise criteria, and this could be a very tiny little response here, and I actually think there is one there, but this is now in our ipsilateral dominant classification, where the ipsilateral channel shows a earlier peaking wave 5 with a larger amplitude. So that gets our classification that there is a response here at this intensity, and I do believe this is a wave 5. And in SimHERA, we could cheat a bit and see this. If you're just in the student version, you can't see that, but I'm going to show you the result by going into instructor mode and showing you, yes, there is a small response in that green line there. Okay, so our judgment was correct. So we've confirmed that we do have a response in the ipsilateral channel, and meaning coming from the ipsilateral cochlea at 60 dB for 2000 Hertz. Now our next priority is find threshold here. So we need to either go down to 50 dB or 40 dB. This is a reasonably large response, so I'm going to go down to 40 dB, but I'm going to keep in masking. Now for 40 dB masking, if we check our nice little chart that we have at the VCHP, the 40 dB is 75 dB SPL masking. I'm just going to clear the right, replot the masked ones down here. And so we're going to go down to 40 dB and collect. I'm not quite comfortable with that one, so maybe one more. Yeah, that's looking like it is noise. And we can confirm that we meet our noise criterion. And yes, we do, and it is flat. So I'm going to classify that as a no response. And then just to show you the contralaterals, it's also flat, and that also gets designated as a no response. So we've got a no response at 40, a response at 60. Let's see what 50 plays out to get that threshold. Okay, so I'm going to clear these again. I'm going to replot those 60s just to give us an indication of where we might be seeing the response being present at 50, if it is there at all. And we're going to go down to 50 here. And don't forget, we've got different masking for 50. It's 85 dB. And we do another replication, looking fairly flat. Not sure, there could be something there. Let's do one more just to be sure if that's a real response. And I'm thinking that might be an actual small response there. I'm just going to do the average and take a look. And yes, it does look like a small response to me. So I'm going to label that as wave 5. I'm just going to double check. Yep, it's 104 nanovolts, which is a fairly large, not fairly large, it's a large response. And that is what I'm seeing. And the SDR is close to 2. So that's another indication for me that it is a likely response. And it somewhat fits the latency delay that you would normally see. And we do have this up and down going in the 3 replications. So response is present. So that makes 50 dB NHL threshold for the 2000 hertz bone conduction. So now that we've confirmed threshold for 2000 hertz, we need to move to the next condition. And that next condition is to do 500 hertz, or you could be testing 4000 hertz. It depends on your clinic and whether or not you're going after the high frequencies or the low frequencies. For SimHERA, it is designated for doing 500 hertz is the next condition. And we go back to the left ear just to see whether or not we have responses for 500 hertz for the left ear. So we change this down to 500, and 35 dB NHL is the maximum normal level. And we're going to turn off the masking just to make sure that we don't have any over masking going on. And that all looks correct. So we go click acquire. And another replication. Looks like there could be something here. So it looks like there could be something here, and that looks like it's in the right interval. There's a little bit too much noise. I'm going to do one more replication just to be sure. There's a little bit too much going on there. That could just be a hump due to noise, but now I'm seeing it in definitely those 2 and as well as a third. So that is a nice replication of a wave 5. Keep in mind that this is for 500 hertz, so your template in your brain, your matching, is not going to look like a 1000 or 2000 hertz response, which you see down here. It is more drawn out and a little bit more delayed, but that's a definite response being present for 500 hertz. Some early clinicians or new students might find it challenging to see those responses, but the more and more you practice it, you will end up realizing that those are responses being present there. If you're unsure, I'm just going to go into here and show you. You can practice this in training mode. I'm just going to turn this on for showing you the signal plus noise here, and you can definitely see that nice signal underneath. We're in an assignment mode, so you won't be able to do that if you have a student version, but instructors can help you out if they want to. Okay, so we've got a response being present at 500 Hertz in the left ear. We now need to switch back to the right ear to see if we've got that same response being present or if it is elevated like the 2000 Hertz. So I'm just going to clear the right and we're going to shift over to the right. So it's good to switch ears and switch AC and BC testing when necessary. Okay, so everything looks good there. Remember, I'm at 8 times speed for collection for the sake of the video. This will take about a minute to collect for each replication. I'm not really seeing anything here. We can quickly do an average, see if that meets noise criteria, and it does, and it's flat. So I'm going to classify that as a no response. So that means we need to evaluate threshold elevation here. We've already confirmed that this is a sensorineural hearing loss by doing bone conduction at 2000 Hertz, so we don't need to repeat it here for 500. So the next thing to do would be to go up 30 dB and acquire. And that is looking like a reasonably nice 500 Hertz response there. And yes, it replicates nicely. Just do that average. So we've got nice responses at 65 dB. So I'm going to hedge my bets and go down to 45 dB to see if there's a response present. Now this might be it with a delay because we are at 40. That's looking like a possible response and it's kind of small. I'm not quite convinced it's not flat, so I'm going to do one more recording. That didn't help too much. So let's take a look at the average, see what the SNR is. It's right in that range. Yeah, if it's small, it's a small response. So if you're not quite convinced and you want to think that is a no response, we still would have to do 50 dB if that's a no response. And to confirm maybe if that is a real tiny little one, I'm just going to mark it with a wave 5 here, just as a question mark. We're going to say peak info. It is in the range of being a real response if that's the amplitude. Around 60 nanovolts, 50 to 60 nanovolts is my threshold for saying if the response is small or not. That's in that range of being a small response, but a possibility. So I'm going to go up to 55 dB because we need to find threshold anyway. It can also be used to confirm latency shifting and whether that response is real. And I'm kind of seeing that that is likely a real one. I'm just going to do another replication at 55 just to confirm. And for after, if I do designate that as a no response, I have my 2 replications above a no response to say, hey, threshold is 55. But I am actually believing that that is a real small response here. And it's kind of following an exponential shift in latency. And the amplitude is a reasonable amplitude for a wave 5. So I'm going to actually lock that in and call that a response being present. So threshold is 45 dB for the 500 Hertz. All right, if you're concerned about maybe a possibility of having some crossover activation because we have a lower threshold in the left ear than the right, we're looking at a difference of, this is a 45 dB stimulus and we're still getting a response here. So that would mean, given an intraoral attenuation in infants using inserts between, maybe the lowest intraoral attenuation would be 40 dB. That means they would have to have a 5 dB threshold in the left ear. I'm not seeing that is likely, so I'm reasonably comfortable that this is a true ipsilateral response. If you were concerned about that, you could do a dual channel recording, or you could put in masking in the left ear. But typically that's not done in our clinical protocols. That is considered a nice ipsilateral response because it is of a lower intensity at 45 dB. So it's not quite recommended to waste time recording masking at such low intensities. It's better to get more information. So the next piece of information we need to get would be for doing 4,000 hertz to see if there's any high frequency loss or even steeper sloping loss for the right ear. And also there could potentially be a high frequency loss in the left ear. So I'm going to stay in the right ear and switch to 4,000 hertz. So I'm going to clear that for the right, and we're going to move this to 4,000 hertz, and we can go ahead and acquire. And we'll do that again here. And those are looking like no responses. And we're meeting noise criterion, so I'm going to classify that as a no response. Again, switching ears here, I'm going to switch back to the left. Okay, so I'm going to just bring that down. Oh, sorry, take it up because we usually go from low frequencies to high frequencies here. And we've got our 2,500. And we're going to do a 4,000 in the left ear. This could be a wave 5 here. We'll need to do another replication. Yeah, that's looking like a wave 5 for a 4,000 hertz response. So I'm comfortable calling that response present. And so now we've kind of confirmed that for the left ear, we have typical hearing, normal hearing in the left ear, at least for 500, 2,000, and 4,000 hertz. You can go off to do with 1,000 hertz as an optional one after we tested the 4,000 hertz or find the 4,000 hertz threshold for the right ear. So I'm going to switch back to the right, and we're going to search for threshold in the right ear. So that means we need to go 30 dB up, so that's 55 dB, and click acquire. And we'll do another replication. This could be something. Yeah, actually, it's not looking that bad. It might be. Yep, SNR above 2. Low noise, that's looking like it. It does kind of match this, kind of in the same range, so I'm going to call that a response present at 55 dB for 4,000. Okay, so next thing to do is, again, now we need to figure out whether we're going to go down to 45 or whether or not we go down to 35. It's kind of a not that small of one. We can check it's in, yeah, it's again 100 nanovolts. Not bad for a round threshold, actually. So I'm gonna, from experience, I'm gonna say 45. We might get a no response there. If we do get a response, we have to go down to 35 anyway. But if we do get a no response, then we do not need to go down to 35. So we're doing a bit of a hedging of our bets for efficiency purposes here. So that's looking pretty flat. So maybe I did make the right bet here. Yeah, that's looking pretty flat. If you're concerned about this being here, I'm just going to acquire another, but we can, while that's acquiring, and you might takes me a short time because I've got it listed as a speed up here. Yeah, we're right. If this was the wave 5 being true wave 5, you're in the 60 nanovolt, 40 to 60 nanovolt range, which makes it unlikely. So I'm going to delete that average, because what we did is in the meantime, we collected another replication there. So I'm going to average those. And yeah, that's now looking fairly flat. So I'm going to call that a no response. We don't have to go down to 35 dB. We could do the 1000 Hertz. It depends on your clinical criteria, whether or not there is a large enough slope between 500 and 2000 Hertz. In this case, it is not, but because the infant's sleeping, we're going to go ahead and evaluate at 1000 Hertz, because that will help the clinicians manage this child if we kind of know that slope, and helping for fitting of hearing aids if they choose that option. Okay, so I believe we've got everything that we need for the 500, 2000, and 4000 Hertz thresholds. We're going to see what the 1000 Hertz is for the right, so I'm going to clear that. We're going to go down to 1000 Hertz, 35 dB. Yep, that looks correct, and we'll collect that. And that's looking fairly flat. Okay, then we just take the average of that just to confirm. And yes, that's a no response there. Now the question is what intensity to go up to next. I'm actually going to go up to 55 because of what we had for thresholds for the 500 Hertz and the 2000 Hertz. It's kind of sandwiched in between there. So we'll label this as a no response, and we'll collect at 55 dB. And that is looking like there could be a response there. I'm just going to collect another replication to confirm. And yes, nice response. And then we'll come down to 45. And this is possibly one there, so let's take a look if that repeats. It's looking like it is repeating. And I'm just going to take an average, take a look at the SNR or SDR. Yes, it's around 2, and that does look like a wave 5. So mark that edge, just check the peak info. Yeah, another 100 nanovolt response, so that's looking pretty good. So threshold for the 1000 Hertz is 45 dB. Now I forgot to mention that you should be doing your recording sheets on the side. I haven't been showing you that. I've shown you that in a previous video, but make sure you're doing your recording sheets and mark down that 45 dB threshold for 1000 Hertz. And just in case the computer crashes, but also for tracking, I knew to go to 55 dB instead of going to 65 dB because threshold for 500 was at 45 dB for the 500 and 50 dB for the 2000. So it's likely that you're going to have a response being present at 55 dB and possibly even 45 dB. So I went a little bit higher than the 50 dB to 2000 just to really see that nice response. I probably should have gone at 45, but it's a questionable judgment which one to go to. Okay, so we've got that 1000 Hertz for the right ear, and this would be sufficient information to make management decisions for this child, but because the child's still sleeping, I'm going to test just for the left ear just to round out our frequencies. And I do expect a response to be present here. It would be unlikely. I mean, the infant could have a cookie bite loss, but those are quite rare in infants. And yes, we do see a response being present here for the 1000 Hertz. Just take an average of that. And usually how we designate these or plot these out, we have low frequencies at the top to high frequencies at the bottom. So there's the 4,000, 2,000, and 1,000. Okay, the next thing for us to do is to confirm the bone conduction thresholds for the 2000 Hertz in the right ear using air conduction. So we put at 50 dB right ear, 2000 AC. That looks good. Baby's still sleeping. Yes, acquire. And we'll do another replication. And that's looking like a response there. If you're unsure, you could do a third rep if you like. I'm fairly confident that there is a response there. Well, maybe not so much given that SDR. I'm actually going to acquire another one just to be sure. Yeah, it's a small little response there. It is present. I'm just going to delete that average and then average these three. And yeah, now we're getting near an SDR of 2, so I'm feeling a lot more confident that we have a response present there. And then we go down to 40. I suspect we should get an NR. And that's not looking like there's anything replicating, and it's reasonably flat. Doesn't meet our noise criteria, so we need to do another one. Not really seeing anything there. Still not meeting our noise criteria. One more replication hopefully should do it. Now it's meeting our noise criteria of less than 0.04, and we can classify that as a no response. Okay, so I'm going to speed up the video and rearrange all of this information. So we've collected all the information that we can from this infant for helping for management. And I'm going to rearrange these things on different pages, do the markings, as well as put in the titles. And I'll come back. Okay, I think we have everything sorted out here. We have our left ear responses at that maximum intensity for normal hearing. Page 1, I put the 500 Hertz ABR thresholds for AC, which you can see here. And it's nice to designate the NHL and the EHL. That's going to help us when we transfer the EHL over to the case report. There is the 1000 Hertz AC, and then page 3 is the AC for 2000 Hertz. And then page 4 is the bone conduction for 2000 Hertz. We are putting the threshold here, so it's 50 dB and 40 dB. You have response present, response absent. For the other pages, that's where we place the intensity levels in which do not bracket threshold. And in this case, we have the unmasked and the masked. And then following that, 30 dB NHL. And then on page 7, we have the 4000 Hertz thresholds. Okay, so we can transfer now these EHL levels over to our case report. So we're doing ABR left ear. We have dB EHL levels less than or equal to 25 dB because they were at that maximum stimulus intensity that we expected to see. Same thing for the AC for 2000 and 4000. We did not do bone conduction because we were at the maximum stimulus intensities for normal hearing here. But for the right ear, I'm just going to go back and remind us what the thresholds were. So on page 1, 500 threshold was 35 dB. So we get 35, AC 35 for 1000, and then 45. So 35, 35, 45 for 2000, and 55. So 35, 35, 45, and 55. Those are for the ACs. So here ABR is 35, 35, 45, and 55 for the air conduction. And we did the bone conduction was also, I believe, we'll just double check to make sure. Go to page 4 here, and it was 45 dB EHL as well. So we can type in 45 dB EHL. And in SimHERA, we can plot those out as ABR thresholds for the audiogram. And we can see the left ear less than or equal to those maximum stimulus intensities, and then the actual thresholds for the right ear. And we can also do tympanometry on the infant. Let's say the infant woke up. Actually, we would have been doing this before. We would have been doing all the waveform manipulations, or maybe the baby was still sleeping. But we can do tympanometry. Let's wake up the baby to make sure that we have normal timps. And that looks correct. And then also OEs. Okay, and I'm designating this as no response because our signal to noise ratios are below the 6, which are our criteria, and they also fall underneath that gray shaded region, which is our confidence intervals for normal. But for the left ear, we actually have responses present for the left ear because they're greater than 6 dB and fall within our gray area for our range. Okay, so we have type A's for the admittance here, so that makes us feel comfortable that we don't have any middle ear issues, which could be reducing the dP grams and elevating the thresholds, but we already figured out that it was sensory neural hearing loss because we have an elevated 2000 Hertz bone conduction threshold here. This concludes all of the information that we need to make our summary of findings and recommendations, and that's what we're going to go to next. Believe we've got everything that we need here, so I'm just going to go ahead and save this case, and I'm going to save it as something different. Say yes. And then we are going to go and save the report in this lab number 5, and that's report 1. Yes, my name, and I'm an instructor, but you put your student number there. Okay, and the report is now printed, and we would send that off to our instructor for grading, as well as that saved case in the .mat file. But before we go, I'm just going to give a little bit of a spoiler alert and find out how well we did with that case, where we are showing 35, 35, 45, and 55 in the right ear. And those are the true values, and here are the ABR values. So we can see that we can correct for dB/EHL that, yep, we had 35 being a little bit higher for 500. It was actually about 25, so we're about 10 dB off on that. And then 35 is close for the 1000, and then 45 is very close. We're doing 10 dB steps, so that's pretty close to the threshold for 2000 hertz, and then 4000 hertz again, we're very close to its true thresholds here. So we did a pretty good job, and we have typical hearing sensitivity for the left ear. So we found the asymmetrical loss with a slight sloping loss here as well. So not bad. Okay, so we would send those things to your instructors, and this concludes our tutorial for testing an infant with unknown hearing who have been referred to you from the newborn hearing screening program. Hope you enjoyed it. Have fun learning. See you next time.